Columbia engineering is very different. I mean, we talk about engineering for humanity, right? I think it's a new way of thinking. Now consequences are everything. What are the societal challenges? So what chemical engineers do is process innovation, is how to take an idea a chemist has and actually take that and make it something that humanity can use.
And many of the grand challenges facing society right now are really central to what chemical engineers do. So addressing issues related to global water, climate, sustainability, these are all things I'm interested in particular, and chemical engineering background really positions students well to go in those directions.
And the chemical engineering department covers a large breadth of topics, from soft matter to electrochemistry and catalysis to bioengineering.
Chemical engineers play a very key role in a lot of applications in society. Nanoscience and how that could lead to new materials. We work on renewable energy, which is important for the sustainable future, and a lot of applications of medicine, developing, for example, new methods of sequencing DNA.
So there's a lot of opportunities for students at all levels to do research and solve design challenges. Starting from their freshman year, they really get involved in the art of engineering and taking the fundamental engineering concepts and then applying them to real-world problems to try and help humanity.
They have great experience in our department because they get exposure to the applications of chemical engineering. And we have lots of new young faculty at the leading edge of chemical engineering, and so they have a chance to understand what are the new trends in chemical engineering, what are the new applications.
So there's a lot of discussion amongst faculty and then amongst faculty and students. So there's no real division. We all sit together and we're all at a lot of the same events. And I think that close connection between everybody really helps spur research progress and intellectual growth.
In chemistry, the focus tends to be on chemical processes at the molecular level. And as chemical engineers, we certainly think about molecules and their reactions, but we're also trained to think about chemically reacting systems on a number of scales. So a process level, system level, maybe on the level of a city or even a global scale.
A very exciting new development in chemical engineering is the establishment of the Columbia Electrochemical Energy Center. Our mission is to come up with solutions to the climate change problem. So we're working with a large number of different industries to understand how batteries can be incorporated effectively into electric cars, for example, and how they can make wind and solar a viable solution to solving the problem.
So there's a lot of opportunities to interact with those companies and have internship opportunities and find out what the problems that they're trying to solve are and bring that into our curriculum.
Beyond the borders of the engineering school, we have a world-class university that's excellent in many different areas. We have experts in public policy, environmental science, the School of Public Health is fantastic, and all of these work together to help us solve problems in a holistic way.
We impact technologies in ways that are really profound, but in very ubiquitous ways. So I don't think there is, I might be exaggerating, I don't think there's anything that chemical engineers don't work on.